Hi, I'm Abdullah Ahmed Muhammad. Yes, that's my legal official name. I'm from Egypt. I'm doing my engineering master's degree in automation and control in the University of RPTU in Kaiserslautern in Germany. And in this video, we are going to explore together the world of robotics through my master thesis project. First of all, I'm doing this project with DFKI in Kaiserslautern, which is a research company, so I'm not doing the thesis with the university, I'm doing it with a company. And I would like to mention that I was working on this project before I started my master thesis as a student job. So the tasks I had before I started my master degree was to do mapping, localization, and navigation. So simply mapping and localization are like the GPS of the robot. Mapping is the task where the robot has to create a map for the environment around it, so that the robot can know the paths that are allowed for it and the paths that has obstacles. And localization tasks mean that the robot knows exactly where it is in this map, so that the robot can know its position and know where it is heading to. So after we did mapping and localization, next comes the task of navigation, which is the robot's ability to move around. We can think of it as the sense of direction to the robot. The robot uses specific sensors to know the obstacles around it, and it can use that information to create paths in its environment. So that when we give a point for the robot to go to, the robot should be able to navigate and move by itself to this goal point without hitting any obstacles. So this was my work before my master thesis. The sensors that were used for these tasks and even for my master thesis, they were LiDAR, depth camera, IMU, and odometry from the robot and from the camera itself. LiDARs and depth cameras are like the eyes of the robot. The sensors shoot laser beams or using infrared to measure the distances to the objects. Using this, we can create 3D point cloud for the surroundings of the robot so that the robot can have a 3D picture of what's around it. I will also do a demonstration to show you these things visually so that you can get a better understanding of what I'm talking about. So now let's go to the master thesis topic and what I am supposed to do. So the task here is that we want the robot to move inside an office, and the robot should know exactly all the items inside this office. So the robot should know that, for example, there is a box, there is a chair, there is a table, and stuff like that. And what if there is an object that the robot doesn't know? Well, the robot has to create a 3D point cloud reconstruction for that object, and it should then send this data to a user, for example, for me, and then I have to input that, for example, this object is a chair, so that next time when the robot is moving in the office, it should know that this object is now a chair. So now the data I had already was point cloud for the environment. First of all, I had to do some pre-processing to this point cloud data. Pre-processing like outlier removal and filtering. The data from the ground and from the ceiling are not needed, so I had to remove them. After this step, I had to do clustering for the point cloud data. And what I mean by clustering is to give entity to point cloud data that relates to the same object. So all the points that are related, for example, to a chair will be identified as just point clouds for this object, which is in this case, the chair. The robot doesn't know until now that this is a chair, but it knows that this is a separate object from anything else. After clustering comes the part for object detection and object recognition. What is the difference between detection and recognition? So with object detection, we know exactly where the object is in space, and we even know its dimensions and its bounds. Then object recognition takes this a step further. So let's take a security camera as an example. With the security camera, we can detect that there is people, animals, and cars, for example, but we don't specify what or who they are. So another example, we can say that we have fruits. Object detection will tell us that, okay, we have fruits in this scene. Object recognition will identify apples and bananas, not just fruits. For object detection and recognition, I use neural networks. And specifically, I used a library called Detection 3D. Detection 3D is an open source object detection toolbox that really simplified using different neural network models to achieve object detection and recognition. So until this step, the robot is moving in its environment and it's detecting and even recognizing what are the objects in its scene. So what will happen now when the robot is moving in its environment and it detects an unknown object? Well, the approach that I created was to move around this object and take different angles for this object. The robot has to use the dimensions of that object to create a specific path around the object. And from that path, it will select some points from where it will take and record point cloud data, and then it will merge the information that it got while it's moving in its path to create a 3D point cloud reconstruction for that object that then can be sent to a user who can then input what object is that. So that next time when the robot is moving in its environment, it should know what is this object. For point cloud processing, I used PCL library and Open3D. And in my thesis, I did a comparison between them. And in my coding, I used Python and C++, but mainly I used C++. All this work was done on the JSON ORM and using the robotics operating system, which is ROS2. So now enough talking, let's see a quick demonstration of how the robot is operating. So we are now in the robot's environment, the office that the robot has to move around and know the objects inside this office. So what you can see right now in the screen, this is the map of the office that the robot did by itself. So the robot moved around the office and it formed this map that you can see on the screen. So you can see the black areas are the obstacles in the office, and the white areas or the gray areas, these are the areas that has no obstacles or no objects. So this is exactly what the robot can see. This is the results from the camera, and you can see the points. I'm not sure if you can see. If we got closer, you can see that these data are actually points. So this is what we call point cloud data, where you can see a bunch of points which represent the environment. So the robot currently can see, for example, this view right here, where this is a part of the screen. So this is the part of the screen. If I moved in front of the robot, so here you can see me, I'm standing in front of the robot, and this is how the robot is seeing me. So this is the result from the depth camera, and it's actually a very dense data. A better idea for mapping is to use LiDAR, because LiDAR has a less dense data, and we don't need that much details when we are mapping the environment. Another point I would like to mention is that the LiDAR has almost a 360 degrees field of view. But when you saw the results from the camera, it had a smaller field of view. So you can see now the result from the LiDAR, and it's for the whole environment or the whole office. So you can see me, I'm right here. If I move my arm, you can see that this is my arm moving. So also you can see that the points are less dense than what we saw with the camera. So the LiDAR was used for mapping, but the camera was later used for the point construction when we want to do a point cloud construction for the unknown object. So I'll bring a chair here and we'll see how the clustering algorithm is working, and then we will let the robot see the object as if it's unknown, the chair is unknown, and we'll see how the point cloud reconstruction works. So let's get started. So first of all, let me show you that this part is now black. So this part under the chair is now black, which means that there is an obstacle that the robot can see now, which is the chair. As you can see, the chair is above. So this area, which is the empty area, the robot can navigate through, but for example at the chair, it can detect that there is an object and there is an obstacle, so it cannot have a path through this object. Let me remove the map to show you better the clustering. So now you can see that the chair has a different color from the surrounding. So for example, here the walls have a different color, and here the chair has a different color, and any object that is far away also has a different color. So this is the clustering part. And you can see that the points for the ground and for the ceiling, they are not there anymore because we don't need them. So now the point cloud data of the chair is just specific for the chair. And now let's see what will happen when the robot detects that this object is unknown. Let's see now. So this is like a top-down view, and you can see that this is the chair. And you can see that there are some color points which are around the object, which is the chair. And the robot will start now moving to these goal points. So now you can see that the robot is started moving, and it's going to these goal points around the object. So it reached the first goal point. Now it went to the second goal point. And while it's going to these goal points, it's merging these point cloud data that it's taking while it's standing. Here still you can see the point that it's going to. So now it is going to this point right here. So now it's going to the last point, which is right here. And then it's done. And here you can see the result that we got from the robot. So you can see here that we have the chair. We can actually move the point cloud data to see what the robot has taken. So you can see the result, and you can actually say that yes, this is a chair. So when the robot sends this data to a user, the user can then input that this object was a chair, so that when the robot moves around the office again, it can know that, okay, this object was a chair. And that's all with this demonstration. And that's all with my master thesis and with this video. I hope you got something from it and you liked the video. If you did, don't forget to like and subscribe to the channel. And if you have any further questions, you can let me know in the comment section. I'll be glad to help. And see you guys in the next video.